Hello, this is Mrs. Scarple with video number 2 for topic 3.12. In this video, I'm going to cover the sum and difference identities as well as the double angle identities. Now for the sum and difference identities, if you just remember what the sum identity is for sine of adding two angle measures and cosine of adding two angle measures, then you'll know the difference ones because it's just the opposite sign. So for sine of alpha plus beta, that's our sum. It's sine of alpha times cosine of beta plus, and now this time it's the cosine of alpha times sine of beta. So sine A cosine B plus cosine A sine B. Now for the difference, that's going to look like sine of alpha minus beta equals, it's still sine of alpha cosine beta, but now it's going to be minus cosine alpha sine of beta. For cosine alpha plus beta, we find the cosine of, or it's the product of the cosine of both angles, cosine alpha times cosine beta, minus the sine of the product of the sine of both angles, sine alpha times sine beta. So cosine alpha, cosine beta, minus sine alpha, sine beta. For the difference, it's going to be cosine alpha minus beta equals, we're still starting out with that cosine alpha, cosine beta, but when it's a subtraction, when we're finding a subtraction of angles, we actually have a plus here. So it's the opposite with the cosine one, sine alpha. And let's write that a little bit nicer. We want to say sine alpha times sine beta. So sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. When it's the difference, we just replace that plus sign with a minus. For cosine alpha plus cosine beta, it's cosine alpha cosine beta minus sine alpha sine beta. When we want the difference, we still have cosine alpha cosine beta, but now it's a plus sine alpha sine beta. And then the double angle identities. There's not really anything more to do with sine 2 theta. You just need to remember that sine 2 theta is 2 times the sine of theta times cosine theta. What's being doubled here could change. So we have sine 2 theta is going to equal 2 sine theta cosine theta. Cosine 2 theta, and the reason these are called double angles is because we are doubling the measure of our angle. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. Now don't confuse this with the Pythagorean identity that says cosine squared plus sine squared is going to equal 1. That's not the case here. We have cosine squared minus sine squared. But if we use our Pythagorean identities, we can write this in other forms. For example, I could write this as, instead of writing it as cosine squared, I could write it as 1 minus sine squared theta. And then we still have minus sine squared theta for an expression that is equal to 1 minus 2 sine squared theta. Likewise, if I wanted to write this in terms of just cosine squared, not cosine squared and sine squared, I could write this as cosine squared theta minus sine squared theta is going to be equivalent to 1 minus cosine squared theta. And when we distribute that subtraction through, we'd have cosine squared plus cosine squared. So that's going to be 2 cosine squared minus 1. Now, if you can just remember the cosine squared theta minus sine squared theta for the cosine double angle identity, you can derive these other two forms. Might be helpful to use those forms when simplifying or rewriting trig functions. So let's practice with some of this. Here I've got the identities again for us. Notice with the sine alpha or sine alpha plus beta and the sine alpha minus beta, when it's adding, we have the adding on top in the symbol here. But for that cosine one, notice the symbol is upside down, and that's because for the cosine alpha plus beta, we do a minus operation. And then we have all of our identities for the double angles. So here we have in example 4, which of the following is equivalent to the expression 2 sine pi over 14 cosine pi over 14? Well, this form tells me I'm looking at a double angle identity. And my theta is pi over 14. So if I want to write it in another form, I can say that 2 theta is going to equal pi over 14. I'm just double checking my notes so that I write this correctly for you here. And I did not write it correctly, so let's pause again. Let me erase this. I apologize if I'm causing any confusion, so we're going to start this over. My theta is pi over 14. As I look at my sine 2 theta, and it has 2 sine of theta, so my theta is the pi over 14. I can write this sine of 2 theta then as sine of 2 times pi over 14, which means I would have sine of 2 pi over 14. And since none of my answer choices involve a denominator of 14, let's simplify this. 2 pi over 14 is going to simplify to pi over 7. And as I look at my answer choices, that is answer choice C. If we look at example 5, we're given a function k is given by k of x equals 4 times cosine 2 of x. Which of the following is an equivalent form? Well, that 4 in front tells me that I'm going to have to take 4 times whatever the double angle simplifies to for cosine of 2x. So if I look at my answer choices, this sine of x, cosine of x, that's a form for the double angle, the sine double angle. So I can rule that out. Cosine squared of x plus sine squared of x, that's more in the form of a Pythagorean identity. It is not an equivalent form of my cosine double angle. So for my cosine double angle, I'm going to have 4 times, and we're doing cosine of 2x, and we know that cosine of 2x is going to simplify to, I'm just going to double check it up here. I want to say yes. cosine squared theta minus sine squared theta. So that's how I'm going to start. Cosine squared theta minus sine squared theta. Or in this case, cosine squared x. The reason I'm starting here, because it's easier for me to remember, okay, cosine 2 theta is cosine squared theta minus sine squared theta. Then I can look at my answer choices and I can see, do I want my answer in terms of sine or cosine, and write the equivalent form. So I see that my remaining choices are in the form of cosine. So I'm going to write this as 4 times cosine squared x minus 1 minus cosine squared x. And when I simplify that, that becomes 4 times cosine squared x. We'd have a plus cosine squared x. So that's 2 cosine squared x plus 1. And if we distribute the 4 through the two terms there, we will have, oops, it's not plus 1 there, it's a minus 1. As I checked my answer choices, it looked like I needed to have a subtraction somewhere. Good thing I paid attention to that. When I distribute the 4, that's going to give me 8 cosine squared x minus 4, which is option C. And if I look at example 6, which of the following is equivalent to the expression cosine pi over 8 times cosine pi over 6 minus sine pi over 8 sine pi over 6? That tells me that I'm looking at the cosine alpha plus beta. I'm looking at the double angle for cosine. So in that case, my theta is going to be pi over 8. So we're going to have cosine of 2 times pi over 8 excuse me, it's not the double angle one. It's just the sum. It's the angle sum identity for cosine. So because it is cosine cosine minus, it's going to be cosine of pi over 8 plus pi over 16. So pi over 8 is my alpha, pi over 16 is my beta. And then I can simplify this to find which cosine expression I want. So the common denominator of 8 and 16 is 16. We're going to have cosine of 2 pi over 16 plus pi over 16. Now that we have a common denominator, we can simplify this into one angle measure, and that's going to be 3 pi over 16, or the value for, or option C. So example 7 is using a unit circle. It shows it's centered at the origin, angle measure of theta in standard position. I shouldn't say that it's a unit circle. Our radius is 13. So we need to find the coordinates of P are 5 and 12. Which of the value, or this is a poorly worded question. It should say, what is the value of sine 2 theta? So if I want to write my ordered pair in terms of sine and cosine, my radius I know is 13. So cosine of this angle, the horizontal displacement from the y-axis is 5. So my cosine of theta is going to be 5 over 13. I need to give myself some room. It's not allowing me to write. 5 over 13. That's going to be my cosine of theta. And my sine of theta is going to be 12 over 13. So when we find the value of sine 2 theta, we know that the double angle for sine of 2 theta is sine of, in this case, it's just going to be theta, sine of theta, cosine of theta, plus cosine theta, sine of theta, which is just going to simplify to, because these are the same, I shouldn't have a plus sign there. Go back, this is just cosine theta, sine theta. Because these are the same, because it's one angle, I know that this is going to be equal to 2 times sine of theta cosine theta, which is my double angle identity for sine of 2 theta. We just derived it. So knowing that, I know that the sine of theta is 12 over 13. So I'm going to have 2 times 12 over 13 times cosine, which we said was 5 over 13. And when we multiply this through, let's see, we'll have 5 times 12 is 60, times 2 is going to be 120 over 169. And that is the value of sine of 2 theta. So when you're given coordinates that are just specific points, you can convert to the cosine theta, sine theta coordinates to help you with solving these double angle identities or even sum or difference identities for these circles.